Good morning, dear 10th class students. I hope you all are studying well at your home. Okay. In the last class, we already discussed about the acids properties. Now we are discussing about the properties of bases. Properties of bases. So let's we have to start about the properties of bases. Okay. You know about that. This is our second chapter, acid-base salts. Okay. Properties of base. Properties of base. First property is bases are bitter in taste. Bases are bitter in taste. Okay. Second property are bases are soapy or slippery to touch. Okay. Third is uh, bases turns red litmus to blue. Bases turns red litmus to blue. Fourth is they are they are generally good electrolytes, good electrolytes under electricity, electricity solution. Fifth, this is when reacts with acid forms salt and water like acid and wedge. Okay. Okay, understood? This is NaCl plus H2O. NaCl plus H2O. This is when reacts with metal forms. And this is reacts with metal forms. Salt plus salt and residual gas. Residual gas. It means when basis reacts with metal, Zn plus NaOH reacts with so Na2 ZnO2 plus H2 and 7 number. Basis reacts with non salt and water. Like bases react with non-metal oxides, like calcium hydroxide when reacts with then formation of CaCO3 plus H2. Yeah, English is sometimes. This is corrosive. So students, I already wrote here properties of bases. Properties of bases. First, we will see the property number one, basis. Bitter in taste. You know about the raw almond taste is a bitter taste. Okay, and sometimes the other some vegetables are having a bitter taste. Okay, not salty here. It is a bitter taste. Okay, and you know about that now here. What is the taste of acids? Sour taste. Okay, sour taste. Bases are generally soapy and slippery to touch. It means when we are touching the bases, then they are just slippery to touch, like a soap solution. Basis turns red litmus to blue. Some more properties you can add here about the methyl orange, how they react with methyl orange indicator, how they react with phenolphthalein indicator, how they react with olfactory indicators. But we are writing only the main properties on the basis of different things. Okay, like red litmus to blue. It means when about acids, the blue litmus paper is changes to red litmus, and here it is red litmus to blue. Next one is they are generally good electrolytes. They are generally good electrolytes, and this is electrolytes. It means they are good. Generally, during the electrolysis, we need some ions dissociation. So, for the ion dissociation, generally we can use acids or maybe the base. But bases are also good electrolyte. Means in the presence of bases, also water can able to, or in the presence of water, bases also can able to dissociate their ions in the form of OH minus. Okay. So conduct electricity in solution. If it is their basic solution, then it can able to conduct electricity. Now second, fifth one is bases when reacts with acid form salt and water. You know about that. This is the form of our neutralization reaction. This is the form of our neutralization reaction, and this already we discussed about in acids also. Okay, in the acids properties also, and this is a very common thing when acid and base neutralize to each other. The formation of salt and water, and this is known as neutralization reaction. This is known as neutralization reaction. So salt and water, acid is acid, NaOH is a base. NaOH means sodium hydroxide. General name is caustic soda. We will discuss further. NaCl salt and H2O water. This is the neutralization reaction. Okay, neutralization reaction. Neutralization reaction. Next, sixth one is bases when reacts with metal forms salt and hydrogen gas. It means when bases will react with metal, then forms salt and hydrogen gas. Same process we already seen in the acids. When acids reacts with metal, it means when Zn react with H2SO4, Zn just displace the H2 from H2SO4, means from displace the hydrogen from H2SO4, and formation of zinc sulfate, that is the salt, and hydrogen gas will be liberated from that reaction. Now we are discussing here metal with our NaOH, means metal with base. So formation of Na2Zn O2. The name is sodium zincate. The name is sodium zincate. Important reaction. This is okay. In amphoteric oxides, coming days we will discuss about the amphoteric oxides, which they are it means react as well as bases as well as acids, and that we will see the sodium aluminate also. Now here is studying about the sodium zincate. This is the sodium zincate, Na2Zn O2, so sodium zincate. Okay, this is also a type of salt, and this is the hydrogen gas. This is the hydrogen gas liberation. Generally, when any gas is liberating, we are it means marking this arrow upside. Okay, basis reacts with non-metal oxides. Non-metal oxide. Carbon is a non-metal and CO2 in the oxide form. When it is attached with O2, this is the oxide form. Formation of salt and water. Formation of salt and water. So when calcium hydroxide is the formation of with the you know about that. This can be formed when CaO reacts with H2O, CaOH whole twice. Okay, and this is our quick line and this is our slick line. Slick. This is a simple line also. So calcium hydroxide. This is the calcium hydroxide. Okay, and this calcium hydroxide is a base. Calcium hydroxide is a base, and non-metal oxide means CO2. When both are react to each other, they just form the CaCO3. CaCO3. This is the calcium carbonate. It is in the different form of like axial and chalk sometimes. So this is the form of this calcium carbonate, generally made of it means the axial also made up of calcium carbonate. Chalk is also a form of calcium carbonate. So this calcium carbonate is formed, and this is the salt here. And H2 hydrogen water will be formed here. Now the strong bases are corrosive in nature. You know about that. If their acids or if their bases, both are corrosive in nature. It means they are just making producing a decompositions in the other utensils or other containers in which they generally filled. Okay, that's why we are generally kept this acids and bases solution in the glass container. Okay, first you have to write, then we are discussing more. Now strengths, we are discussing about the strength of acid and base solution. Okay, so strength of acid and base solution. It means pH scale. Okay, what is the pH scale? Strength of acid and base solution on pH. First is that you know about the water. Generally, water are having a neutral in nature. As neutral in nature because in water there is a combination of acid and base. It means there is a no perfectly acidic in nature, no perfectly basic in nature. That's why generally we call water as a universal solvent also, and water is as a neutral solution. So water generally neutral in nature. Next, acid. Acid has excess of hydrogen ion concentration. Next is bases have excess of hydroxide ion concentration. That means H plus OH minus H. Next is, now we are discussing about the pH scale. Once we will revise here this point. What is this? It means acid have an excess of hydrogen ion concentration. In acids, generally we see that hydrogen ion concentration are good in nature. So generally they are having the H plus ions, H plus ions. Because in roughly we can see for timely like that, when HCl dissociates, then H plus and Cl minus form, Cl minus form, and when NaOH dissociates, formation of Na plus OH minus N. So this OH showing the basic nature, this H plus showing the acidic nature. This is showing the acidic nature, and this is showing the basic nature. Okay, I hope you understood this about what is this OH minus ion and what is this H plus ions. So when OH minus ions in any solutions are good, it means they are showing the basic properties, and when H plus are there, then they are showing the acidic properties. Here it is also. So H plus ions, hydrogen ions also concentration in base, but they are in very less amount. They are in very less amount. So generally we seen only the basic properties or basic characteristics in OH minus ions. I hope you understood this. Now third one is we are discussing about the in 1909 Sorensen, German, okay, devised a pH scale which shows the acid as well as base uh, as well as base nature by showing the different strength of H plus or hydrogen ion concentration by pH values. Okay. So what is this? Now we are showing the H plus ion concentration. H plus ion concentration shows acidic values, and hydroxide ion, it means OH minus, shows the basic values. Before that, when we are discussing about this, we have to see what is the pH strength and what is the hydrogen ion concentration strength. So pH strength, listen, inversely proportional to hydrogen ion concentration. It means that we will see here, downside here. What is the meaning of this? So before that, I want to make. I am making here one pH scale. Okay. Through that, we can understood more things about the pH scale. Okay. Or pH values. So first of all, we will mark here from 0, 1, 2, 3. I'll put here 7. Here it is. So 1, 4, okay, 5, 6, 8, 9, 10, 11, 12, and 13. This is our pH scale. This is our pH scale, and which is showing the different values and how they are showing the different values of this pH. You just the basic thing is that what is shown by pH. What is shown by pH? So it just shows only that how much strength of acids and bases in any solution. It means what is the strength of H plus ion concentration and what is the strength of OH minus ion concentration in any solution. This is the main function of this pH scale to show. Okay, so first of all we will categorize in different values. Like this is the neutral values. This is the neutral values. Why we are calling this neutral values? Because this is the pH of water. This is the pH of water. And now we are categorized into four different categories from like 0 to 3.5, 3.5 to this to sorry to this 7, and from 7 to we are categorizing 10.5, and this from 10.5 to 40. Okay. What is this showing by? Listen, this is strong. This is strong acid. This is strong acid. This is weak acid. This is weak base, and this is strong. You know about that strong acids and strong base. Both are corrosive in nature. Both are corrosive. It means their nature are just making the decomposition and decaying nature. Okay. So I hope you understood about that. This is the neutral. Can I rub this from here? Okay. So it will show clearly for you. Because I can write here. This is the neutral. This is the neutral value for us. This is the neutral for us. I hope you are understanding now more clearly here. So this is the pH values of 0 to at least 3.5 is a strong acids. This is the weak acids. This is the weak base, and this is the strong base. Okay. So you can see here what is the strength is going on and what is the increasing of any acidic behavior or any basic behaviors. Okay. So when you will look from this way, look, okay, from neutral value here, acidic character decreases. Acidic character decreases when we are going from 7. Sorry, acidic character increases. Acidic character increases. Acidic character increases, and from 7 to 1 when we are going, the acidic character increases, and from 7 to 14 when we are going, okay, from here, then basic character increases. Basic character increases. So when we are going from here, okay, from here, so H plus ion concentration increases. Okay, H plus ion concentration increases, and here OH minus ion concentration increases. Okay, OH minus ion concentration increases. Here pH values, pH values decreases. Here pH value, pH increases. Okay. So more characteristics you can just make the reverse in form, like if acidic character increases. Okay, listen. Once we have to revise from this way, and after that we will reach here. Okay. So strength of acid and base solution pH scale. pH scale is a type of scale. It means devised by the Sorensen in 1909. Okay. And one more thing I am reminding here, and that is the means of this pH. This is means of this pH. So P means potence. This is the German word, okay? German word. German, and means power. Means power. And H means hydrogen ion concentration. Okay, I hope you understood here. Okay, we are revising here. Strength of acid and base solution. Strength of acid and base solution means pH scale. So water generally neutral in nature. It means we can say the pH of water is pH is 7, because this 7 pH showing the neutral nature of any solution. Neutral nature of any solution. It means not perfectly contain any acids or perfectly contain any base in nature. Okay, so this is the pH of 7. This is the pH of 7 showing by the our water. That means the distilled water. You know about that. Distilled water is having a pH of 7. Generally, rainwater conduct electricity. Rainwater conduct electricity because rainwater contains too many salts. Maybe the calcium and magnesium salts and sodium salts are there, and some acidic nature also mixed with the rainwater, because sometimes acid also goes there on that time. Maybe the pH has just decreased on that time. pH decreases means the acidic strength is increased. Okay, so that's why they are just showing the good electrolytes. Good electrolyte means they are showing a good electricity in solution. So rainwater conduct electricity because their ions are, because their ions are just showing about any acidic or maybe the salts or like that. And when acids and salts are in our solution, they are generally a good conductor of electricity. So distilled water showing the pH of 7, which we already we can use in car batteries or like that. So next is acid have excess of hydrogen ion concentration. In the acids generally H plus ion concentration are more, and in the bases have excess of hydrogen ion, hydroxide ion concentration. Hydroxide ion means OH minus ions. OH minus ion concentration are good in nature. Now pH scale. Now pH scale. pH scale is a scale which is devised by Sorensen in 1909, German scientist, and which shows the acid as well as base nature by showing the different strength of hydrogen ion concentration by pH values. These are the pH values. On these pH values showing the different hydrogen ion concentration. This hydrogen ion concentration shows the any solutions nature, like maybe acid or base. So now next point is pH strength is generally reverse. It is inversely proportional to hydrogen ion concentration. Once I remind you, when any thing is inversely directly proportional, it means if one is increasing on going on, then other one is also will be increased. But when we are telling that any substance or anything is inversely proportional, it means if one is going to be increased, then other one which is showing in the inverse form, that is going to be a decrease. That is going to be a decrease. It means what is the mean of this formula? Look here, from up to here and up to here. pH strength is inversely proportional to hydrogen ion concentration. It means when we are going from 7 to 0, hydrogen ion concentration are continuously increasing, but the pH strength are just decreasing, because pH is going from 7 to 0 is just decreased. It means if pH is 4, then pH is 4, and when we are comparison with pH 4 or maybe pH 2, here hydrogen ions are weak in acid. It means a partial dissociation of this hydrogen ion, and maybe sometimes we can say this is the weak acid. It means some less amount of hydrogen ions concentration here. But when we are talking here about 2, this 2 pH values having more hydrogen ion concentration. So we can say that when we are talking here from 4 to, when we are going from 4 to 2, there are hydrogen ion concentrations are just increase. Hydrogen ion concentration are increased, but pH strength, if its pH values are just decreased from 4 to 2. I hope you understood about that. What I am telling here, it means when pH strengths are going from 7 to 1 are just decreased, but when these pH strengths are decreased, hydrogen ion concentration is increased. So next one is, what is the mean of this potence? So pH, and we also can say this one sometime, this one, okay, in the form of H, and this way, okay, this is the H plus, it means the hydrogen ion, okay, and this square bracket is showing the concentration of hydrogen ion. This is showing the concentration of hydrogen ion. So pH means, P means potence, is a German word, and means that power, and H means hydrogen ion concentration, and we are generally writing in this way, okay. And for hydrogen ion, for hydroxide ion also we are writing like this way, like OH minus ion. So I hope you understood this thing. 0 to 14, this is the different pH values, and this pH values having a 1-7 values of neutral pH. This neutral pH, in this we are just categorized in 4 different categories. And these 4 different categories are like strong acid from 1 to 0 to 3.5 or like that, and 4 to 7 or 3.5 to up to 7 is there a weak acids, and from 7 or more than 7 to 10.5 there is a weak base, and from 10.5 to 14 is a strong base. So what are the criteria I am using to write about that? So look here. Acidic character increases, and acidic, that means when I am going from 7 to 0, acidic character increases. When I am going from 7 to 14, basic character increases. Okay, next, when I am going from 7 to 0, H plus ion concentration increases. Okay, this is the increase I am writing, and this is the increasing because H plus ion concentration increases, and this is OH minus ion concentration increases because OH minus ions in the base. Next one is pH values are generally decreased when we are going from 7 to 0, 7 to, because it is the general numeral values, okay, and from 7 to 14 when we are going, pH values are generally increased. In next things we are discuss about their salts in next videos, and salts and the color of this different type of strength, okay, color of this, and I hope we can see the color also here, okay. So you know about that color is not a big things, because color is a very simple things, and we can see that the color also here, okay. So we will make a pH different color paper, and through that we will see the colors, okay. Thank you.